Hello everyone. Good morning, good evening. Welcome back. This is Rakesh Jaiswal. Once again, we are going to deep dive into Microsoft Azure Service Fabric. It is part two. Uh, in this session, yeah. So again, it's overview, and in this uh, walkthrough, in this video, I would like to go over application development and the Azure Service Fabric, microservices. We will be looking into more detail and the reliability, scale out, how it works, and lifecycle management. So, application development in age of cloud, right? So, as this image explains about cloud provides managed services, uh, which allow us to deliver feature faster, and which creates a business value. So cloud by default, it's provide or take care of scalability, availability, latency, lifecycle, data integrity, and portability. And this is the other side of a cloud. And from business side, this business version or business need to come up with features, and developer need to focus on feature. So cloud service architecture. Uh, so it's not about service fabric in cloud service. Uh, uh, how it has been developed, even any service or whatever we are going to develop as cloud native application or services. Uh, what is the difference between traditional and microservices way? So in left side you can see that in traditional way we where have now user interface, business logic, and data. And this composed an application. So we were deploying user interface or business logic or data in different tiers. So that's how we were doing earlier. But in microservices, user interface composed of different uh, based on the slicing, right? Like the primitive and or any other instance, where we can slice our user interface, business logic, and data in a small microservices. Uh, so that's how we can, and that can be scattered around the cluster, and that will work as an independent service, and it can scale out and scale in based on demand. So, what is Microsoft Azure Service Fabric in context of application development? So it's a platform, right, for Microsoft's service-based application, which provides reliability, hyperscale, uh, features out of the box. So in this image, you can see, and on the top layer, we are having all our microservices, which has been powered by Service Fabric. Uh, and in Service Fabric, it provides high availability, simple uh, programming model where you can simply develop your application based on your choice of language or underlying environment. It's provide hybrid operations as well. You can run it in local cloud, and it provides high density. Those resources can be utilized more compared to earlier. So yeah, you can deploy the high dense services, hyperscale, data partitioning. Leveraging, you can partition data that can run in different modes in different containers. Rolling upgrade, which is featured there, you can services, automated rollback if there is any issue in the new release of your service, it will roll it back. Uh, the low latency because services and data is composed in any service, so it will be low latency. You can develop the stateful templates and its placement containers constraints, right? Placement constraints means how many instances you want to be running in the cluster for a microservice that you can define. Health monitoring is out of box. Another service would be quick monitor, fast startup and shutdown for any service if you want to scale or stop particular node, you need to stop and expand on the fly. Container orchestration and lifecycle is provided in the service fabric itself. Load balancing across your services in the cluster. It's out of the box. Half filling, if any problems comes in, the gets down, it will expand to user and it will keep provisioning services. And next is replication and failover. So that's the replication factor. It will replicate your services. And if there is any issue with any service code, failover services. And underneath the service fabric here, you see right either we can deploy Azure with Microservice server, and in on-premises private cloud we can also utilize it in our and in other hosted cloud, any other cloud, you can go and deploy the your microservices with our service fabric. So uh, here, metal hardened for complex service. Uh, they have they use it. It's a well proven framework from the Azure. They have been using this service fabric for their all of the services being offered in the Azure SaaS or PaaS model. So, for example, Azure core infrastructure like thousand of machines, uh, provisioning, all that is being taken care of. Service fabric itself. In Azure operating millions of applications per minute, and that's making scalability easy by Azure Service Fabric itself. Intune, yeah, it had 20 devices, and if Sky for Business hybrid of groups is being taken care by Azure Service Fabric itself. And it has Power BI, right? Power BI is also powering Azure Service Fabric, Azure SQL database, 1.4 billion databases. It's being provisioned and it's getting updated as well. Bing Cordana, 500 million operations per second. Event Hub, that is one of the uh, most popular important device to ensure communication. And apart from this, there are a lot of services like IoT Hub that is also doing demand services like Power BI services. So this dashboard shows the power of Azure Service Fabric. So Microsoft Azure Service Fabric, right? So this is a platform reliable and scalable with integrations nearly complete. How For example, here you can see how it's being designed. So at top layer, it contains application program where it's provide you flexibility to develop your application from different type of runtime, and it's take here present metadata of the users and manage management. There is another component through which you can manage the user service metrics like cluster management, node management, all those different services is here. Communication, you can maintain the fast access systems. These are the main component which responsible for application to communicate with federation document and and then testability. So testability will make sure that what is this current status of the applications. So you need to get all running already all so all those things testing about everything on time. So yeah, let's deep dive into microservices. What is microservices? And yeah, so microservices is nothing but a monolithic state that is independently person deploy and scale. So this logical business execution uh, code, right, which also can be attached with state. So that's your one business, including where you can execute your logic. And it has a unique name that can be present. Since microservices which you require, for example, your profile, user profile, to manage your product. In product, there are a lot of sub-products. So there will be different services which will be responsible for those services. So, and those services will be running in a number of instances or cluster. So, uh, how communication between these inter-services happen. So that's where services is named. And it will internally being resolved from the end user point of view. It will maintain manage those. The second point is interacts with other microservices over well-defined uh, protocols matrix. So in your cluster, you will be deploying a number of microservices. So in between microservices, communication will be happening, and definitely there is a very critical role in developing service. And next is it like it remains always logically consistent under this operation. So it is easier for us to build and deploy our services and making sure that it is highly logically consistent with the number of things. It was very easy and we were spending a lot of time designing for that. But here it's being taken care by a central container hosted inside a container. So we have an another session on container. Container is nothing but where our code will be ready, irrespective of runtime. So our code and runtime will be packaged together and it will be running in the container. So, for example, core center applications. Uh, yeah. And microservices can be written in any language framework. That's the one very good beauty of microservices. So, in your organization, you have a number of teams and a number of skill teams. So, based on their choice of language and comfortability, they can choose the language and they can develop that particular microservice. And other team can develop into their own choice of language. For example, Node, Java, or anything else. And that can be deployed into microservice fabric and they will be monolithic and they can seamlessly come together with the rest. It doesn't matter. As long as you are following the microservices patterns. And it can be deployed by small areas. Don't need release management or release products team. So that can be managed. So deployment by a small Indian team, it's pretty easy. And next, I would like to discuss about why microservices approach. Why we need microservice approach? So, as software developers, right, there are nothing new with how we think about factory and application component part. Uh, it is a central paradigm, right, of object orientation, software abstraction, and componentization is right. And today, this factorization takes to take the form of classes and interfaces between shared libraries and technology layers. Right? Typically, uh, tired approach is taken with backend storage, middle tier business logic, and front-end user interface doing. What has changed over the last few years is that as developer are building distributed applications that are for the cloud and driven by the business. That's the nowadays we are. The challenging business needs are nowadays a service that builds and operates at scale to reach customers usage of single reason, right? Yeah. So services that's build and operate at scale to reach customers who give them development reason and faster delivery of features and capabilities to be able to respond to the customer demands in agile way. Right. And third challenge is improved resource utilization to reduce the cost. So this is key major challenge for current trends of development. So these business needs are affecting how we build application, right? So uh, th- that's where we have to tend to new state. Okay, so what, we will deep dive into monolithic based microservice design approach. So all applications evolve over time, right? Successful applications evolve by being useful. not able to evolve eventually or deprecated from our business. Uh, so the question becomes, how much do we know about our requirements today, and what will they be in the future? For example, let's say that you are building a reporting application for a department. You are sure that the application remains within the scope of your company, that and that the reports are short-lived. Your choice of approach is different from, say, building a survey that delivers the video content to tens of millions of customers. Sometimes getting something out of the door as proof of concept is the driving factor, while you know that the application can be redesigned. So there is a little point in over engineering something that never gets used. Right? Uh, it is usual engineering trade-off. On other hand, when companies like talk about building for the cloud, the expectation is growth and usage. The issue is that growth and scale are unpredictable. We would like to able to prototype quickly while also not knowing what that we are on the path to deal with future success. This is the lean startup approach: build, measure, learn, and iterate. So this is how nowadays thinking is. So during the client server era, right, we tended to focus on building tired application, tired presentation tier, application tier, middle tier, service tier, data tier, uh, and these kind of applications. Using specific technologies in each tier, we can use different technology. The term monolithic application has emerged for these approaches and applications. The interface tended to be between the tier or tier and more tightly coupled design was used between components within the each tier. So each tier were having each component. Developer design and factored classes that were compiled into libraries and linked together in pre-executable and DLLs. That's how developing monolithic. After that, there are benefits to such monolithic design approach also. We cannot deny completely. It's often simple to design and it has a faster calls because if those components are tightly coupled, the call will be faster. Because of these calls are often over the inter-process communication. Also, everyone takes a single product, which tends to be more people resource efficient. So it was a single product at that time. It was so enterprise scale. So that's that's where we are fine. The downside is that there's a tight coupling between tiered layers, and you cannot scale individual components in each tier because one tier was getting deployed together and managed together in the infrastructure. If you need to perform fixes or upgrade, you have to wait for other to finish their testing or development so that you'll be able to deploy a whole tier together. It is more difficult to be agile. So uh, the monolithic was blocking us to become agile. So microservices address this downside and more closely align with the preceding business requirement. But they also have both benefits and liabilities. The benefit of microservices are that each one typically encapsulates simpler business functionality which you scale up or down, test, deploy, manage independently. This is the benefit of microservices. One important benefit of a microservice approach is that the team are driven more by business scenarios than by technology. So in this way, in Agile or microservices way, the team will be focusing more towards business scenario. They can use any technology based on their choice. So there is a flexibility, which the tiered approach uh, doesn't encourages, right? In the practice, similar teams develop microservices based on customer scenario and use any technology of their choice. In other words, the organization doesn't need standardized tech to maintain microservice application. An individual team that owns service can do what makes sense for them based on the team expertise or what's most appropriate to solve that particular business scenario. In practice, a set of recommendation technology such as particular NoSQL store or availability value is preferable. The downside of microservice, we will like to discuss that part as well, comes managing the increased number of separate entities. Because when slicing one service, small services, there will be number of entities and dealing with more complex deployment. And in that scenario, earlier we were deploying one tier. In this case, we will be deploying 50 individual services. So, managing at the infrastructure level, the complexity could increase, and versioning was the another challenge. How we can version it? If someone wants, some clients or consumers are using version one, someone want to use version two, and apart from that, if you see network point of view, so network traffic between the microservices increases as well as the corresponding network latencies. Lots of chatting, regular services are the recipe for performance nightmare. Without tools to help view these dependencies, it's hard to see the whole systems, right? And standards make the microservices to work well. They agree on how to communicate and begin uh, tolerant of only the things you need for a service rather than uh, rigid contract, right? So it is important to define these contract upfront. Which, before designing microservices, you should be focusing on what are the contracts I need to expose through which other services will communicate with my service. Uh, uh, Yeah, and because service updates independently for each other. Another description point for designing with the Microservice approach is fine-grained service-oriented architecture. That's tend us to think around fine-grained service-oriented architecture. Earlier, it was SOA, and we have to fine-grain it, and that's where people were starting saying uh, microservice or mini service, right? So, and it's simple, uh, and it's a simple way. The microservice design approach is about decoding or decoupled federation of services which independently can change to each other and agree upon standard for communication. So, all this federation of services will be agreed to communicate with each other through a contract with a particular standard. So, a monolithic app it contains domain-specific functionality and then normally and is normally divided by functional layers. Right? And each so one application can be divided domain-specific functionality and yeah, yeah, and divided by the functional layers such as web and in monolithic way. And you scale monolithic application by loading it on multiple servers or virtual machines or containers. That's how we were scaling. A microservice application separates functionality into separate services. So here we can separate functionality, take one functionality, we can develop a different n number of microservices from that functionality. Microservice approach scales out by deploying each service independently. So once we will deploy, we can independently scale it by creating instances of these services across the servers, virtual machines, and containers. Designing with microservice approach is not a panacea for all, right? But it does align more closely with the business objectives, right? As we discussed earlier. So, starting with the monolithic approach might be applicable if you know that you will have the opportunity to rework the code better into microservices because nothing hard and fast. More commonly, you begin with monolithic application and slowly break it up into stages, starting with the functional areas that need to be more scalable or refined. So to summarize, microservice approach is to compose your application of many small services. The services runs in containers that are deployed across the cluster of machines. Smaller teams deploy a service that focus on a scenario and independently takes version, deploy, and scale each service so that the entire application can solve. Entire application can solve this concept and it can evolve. So for microservices, there are different definitions. If you search in internet, you will find many institutions that provide their own viewpoint and definition. However, most characteristics as decoded here widely agree upon. So, microservices encapsulate a customer or business need. What is the problem you are looking to solve? That's its focus on a particular business scenario. Developed by a small engineer, right, engineering team, written in any programming language and use any framework. Uh, Consists of code and optionally states. It it will consist of code plus its state, both of which are independently versioned and deployed and scaled. And it interact with other microservices over well-defined interface and protocol. And it have unique name URLs, right, used to resolve their location, uh, and remains consistent and available in the presence of failure. So when failure happens, it heals itself. So that is microservices. Uh, so it can be written in any programming language, and it allows code and state to be independently version and deployed in scale. Uh, so there are a lot of approaches, right, to develop microservices, which is we call stateful and stateless microservices. And yeah, so that's how it's microservices all about. And you should be having uh, in microservices to challenge, to remediate with challenge, right? To make it remains consistent and reliable always. We have to have reports of health and diagnostics. So in many uh, scenarios, it seems obvious, right? And it is often overlooked because we don't think about this to get the diagnostics how our service has been ran throughout. We haven't have any, we don't focus more about our services, but it is very crucial to in case of microservices. Uh, Microservices must report its health and diagnostics. Uh, Otherwise, there is a little insight from an operation perspective. Correlating diagnostics event across a set of independent service and dealing with machine clock tweaks to make sense of the event order. All these are challenging, right? So, going into machine, seeing the logs, then looking into its diagnostics, it's not that easy. We should be having system around it which can report the health. In the same way that you interact with the microservice over agreed upon protocol and data format, uh, there emerges a need for standardization in how to log health and diagnostics event that ultimately end up in an event store, right, for querying or viewing. In a microservice approach, it is key that different teams agrees on a single login format. Different team can use their own choice of language platform, but for logging there should be having a centralized so that for whole application stack even we uh, this needs to be consistent approach to viewing diagnostic events in the application as a health is different from diagnostic. Health is about microservices reporting the current state to take appropriate action. Right. A good example is working with upgrade and deployment mechanism to maintain availability. Right. Although the service may be currently unhealthy due to the process crashes or machine reboot, the service might still be operational. The last thing you need to make this worse by performing an upgrade, right? At that time, if it is uh, too busy and at that time you are performing upgrade, the best approach is to do an investigation first or allow time for the microservices to recover before doing upgrade. Health events from the microservices help us make informed decision and in effect help create help us to create a self-healing service. So all these are the challenges in microservices. Right? So how Service Fabric as a microservice platform solve this problem? So Service Fabric emerges based on combination of Microsoft Azure delivering box products, which they are typically monolithic in style, to delivering services. The experience of building and operating large services such as Azure SQL database and Azure Microsoft save service fabric. The platform evolved over time as more and more services adopted and production. The service fabric had to run not only Azure but also standalone Windows Server deployments. So service fabric provides a few broad areas to help you build applications that your microservices use. So it is a platform that provides system support to deploy, detect and restart web services, discover services, route messages, manage state, monitor health. This system service in effect enables many of the characteristics of microservices previously we have discussed. And it also provides the ability to deploy applications either running in containers or as a process. Service Fabric is a container and process orchestrator. Uh, productive programming API, right, to help you build applications and microservices that is broken code, reliable actors, reliable services. You can choose any code to build your microservices, but these API make the job more straightforward and they integrate with the platform at a deeper level. In this way, for example, you can get health and diagnostics information on your service, or you can take advantage of built-in availability. So there will be some approach, right? Migrating existing application to Service Fabric or microservices. A key approach to Service Fabric is to reduce existing code, okay, and which can be then can be modernized with the new microservices. There are few stages to application modernization, and you can start and stop at any of the stages. So these are, for example, start with a traditional monolithic application, okay, and do the lift and shift. Use containers to or guest executable to host existing code in Service Fabric. Okay, then modernization in container state. New microservices you can keep on adding side existing containerized code. Okay, and innovate. The fifth step you can take innovate where can break monolithic into microservices purely based on need. If you see that okay, this particular bunch of the functionality, I can decouple and build it as a microservice and take it, move innovate it, and transform it into microservices. So gradually, the transformation of existing monolithic application or building a new greenfield application, you will be able to achieve it. And it is important to emphasize again that you can start and stop any of these stages. Means, if you are satisfied with uh, left and shift, go with that. No need to be more focused on developing microservices upfront. So these are the microservices, and in a general way, how to develop, how these are typed, right? So type of microservices are stateless microservice and distributed microservices. So it has either one state or it can be retrieved from external store. Okay, like any state management, cache, and there can be in instances for stateless microservices. For example, web frontend for protocol gateway is a cloud service, for example. Stateful microservice, it may maintain an authoritative state. Means only that microservices can access that store, state store. And n consistent copies will be replicated. Means if through the replication, local persistence. So whenever it replicates, it will replicate with O plus its state. For example, database, documents, workflow, user profile, etc. So yeah, I would like to show stateless microservices demo. Uh, yeah, again, federation and transport subsystem of that user service memory. So typical data centers, right? How the typical data center works. We will visualize from data center point of view. Set of independent machines where at that time physical virtual boxes. And we were forming cluster, let's say federation of machines, a set of machines that service fabric prestigious. Earlier it was less, and now once you will install the service fabric, it will stitch all those machines, and it will call nodes, and it will form a cluster. Cluster can scale up to thousands machines. Uh, yeah, a machine failure detection. Here, just here is how machine failure will be getting detected. So, for example, this is the one-time sales where usually machine the time when they are communicating. But in later point of time, these two nodes will interact. So, service provider will automatically span the node, and it will get joined with the cluster, and it will get clustered together, and failures are detected and remediated. Uh, so, cluster system view, how it is. So, how many systems we have in our transport and so, for example, we are discussing about this federation. We already transport how this federation and transport moves together, and how other systems are helping it to make it happen. system, we are having system services like failover manager, cluster manager, link, and image store, where our deployable image will be getting stored, and also for new machines, uh, we have image store over there because of that request. So these are the top level for system services, and these services will be running at least half of the node. It will be scattered at least three replica on these services across the cluster. For example, failover manager, it is and cluster manager is three nodes. Similarly, services also running in three nodes. Image store is also running in three nodes. So, yeah, Service Explorer, I would like to explain. The reliability subsystem. Now, this reliability subsystem. So, they, they are backed with a load balancer. And for example, this is a front end state based lab right here. And they are communicating with individual stateless middle-tier microservices, which are having their own subset of data store. And so it can scale with partition store and increase reliability workflows if you want to have a reliable system. It will be automatically reduce read latency with caches. They can introduce introduce a cache and it will reduce the read anyway. Manage your own transaction state, transaction of state consistency. So state will be either inside the cache or the state will be stored outside of the service or will not be having state at all. Okay. So if you want to implement any transaction, right, so you have to uh, write for it to manage the transaction for maintaining the state system. So, for example, one instance of a service running in two or different instances. So you have to write a code in such a way that it will make sure the state is consistent. And in this pattern, right, there are many moving parts which needs to be maintained. Shared service, you will see that it's a simple design reduce latency. So this way you can see that application lives and community reads behavior. And low latency reads writes will be using partition first class scale out. So whenever you are doing partition, you have to keep in mind for a scale out purpose. And here, because it will scale out even if it's state, so transaction is inbuilt. Fewer moving parts in this scenario, and there will be another data store for analytics or research to memory internal instance. So, yeah. So, stateful microservices are reliable and consistent. Each services is backed by a data set to make its internal state reliable. All replicas are logically consistent. It is logically consistent, meaning all replicas will be same. Line, linearized are the of the read and the write operations to initiate a state. So you can even sourcing patterns or you can utilize read replica and all reads will be happening from Read write of forum. So you will be defining read write. These are services to read. These are services to write. And replica set. That is dynamically configured. We found variables and replicas. So based on the demands, it will scale down. So stateful microservices. Let's see. So we are having services which were deployed. And in this stateful services will be the primary, and the other will be the secondary. So primary services will be responsible for L1, there is one primary, and two secondary. And for flow, there is two secondary and one primary. And all will be retaining replication. So replication, read or completed at the primary. So instead, all read will be happening from the primary. So for example, this is a scenario. This is the primary, and this is the secondary, which is the replica. Primary is aware of all this. So all reads is happening at primary, and primary will serve that primary. For write scenario, write are dedicated to write forum of this second. So for write request, first it will go write on all secondary services. So and then it they will uh, notify back or acknowledge back to primary. So primary one will not make it or not acknowledge this right request until more than 60% or 70% of secondary node acknowledge this right. It will wait for acknowledgement, and after that it will acknowledge. Suppose some of the request, for example, acknowledging later, that's fine. Otherwise, it will try to replicate with it will decommission this service and secondary service and replace with. So reconfigurations, type of reconfiguration scenario in the case of primary failure, secondary service, how it will be managed. So primary failure, suppose primary service is failed. So how it come? So in that scenario, what will happen? Any one of the secondary will take place of primary, and it will remove the failover, and for removing failover secondary in the second scenario, it's any secondary gets failed, how it will manage. So secondary will get cloned with primary, new instance will get cloned with primary, and it will back here, and yeah, so yeah, it's cloning with primary, and it will become the secondary, right? And suppose if you want to add a new secondary because of the demands, so new instance will process or table will encamp, and it will get synced with primary, and after that it will get attached the replication backend, and it will get secondary. So must be safe in the presence of cascading failure scenario, and replica states, right? How many replicas we want. So replica will get maintained. No idle secondary, active secondary, primary. So this is the next one, microservice placement and failing. So how these are the 100, node 103, node 4 and 5, node 5. This is one of the cluster where we are having 5 nodes. And we have deployed one service which is getting depicted with red color. So one of them is the primary and the three are the secondary. Similarly, we can deploy another service contained deployed across the cluster. This is the deployment history where it will be able to find these things for them. Second, like so in this way we have deployed all services. In case of node fail, right? Node 103 is getting failed. How it will be getting failed? So in that scenario, all these nodes will be sending messages across to find primaries or any service primaries down. Any secondary will take place as we discussed earlier, and they will start communication with each other irrespective of that node is not in sync where it is got down. So that's how it will get remediated in case of the failure. So application lifecycle management, how application lifecycle will get managed. I'd like to move forward quickly. So application logic grouping of microservices for any application. Okay. So this is one application which composed of all these four microservices, and these microservices will be deployed through a container into the cluster. So these are get into container and get deployed into this cluster with the four, right? And now this logically following our communication, and they will keep on communicating internally based on their service. Application lifecycle management. Yeah. So, for example, application lifecycle management, provisioning and deploying of constituent microservices, upgrade microservices without loss of availability, monitor microservices. We have discussed all this earlier, so I don't want to delve more in detail. Interface with the scene management layer for auto scale and initiating reboot, repair, replace and repair actions. It provides operational insight into aggregate utilization, inventory, performance, counters, metrics, etc. for traffic management. So, yeah. So, upgrading services with zero downtime as it is slowly upgrade. So, these are the services which are already in cluster. And if this, for example, if yellow is having new day, but go and deploy into the book, and it will see itself how it's working. If it is going well for some time, then it will do the routing upgrade to another node. So that's how it will be upgrading services without any time. Testability subsystem. Is it, so it will be maintaining all remote things and how to get it. So all those operations will be responsible for the testability subsystem. Azure Service Fabric in a nutshell. So it is rapidly developed microservices-based application. So HTML or HTML services you can develop where you can use Visual Studio tool. You can focus on feature, not infrastructure, and it provides again operate reliable, scalable service. It's provide operations around it, right? So automatic orchestration, hybrid operations, self-healing. So this is comprehensive. Yeah, and that's why the confidence of that testing. That's one of the factors where you during confidence of Azure Service Fabric, which has been already tested and currently a lot of services and infrastructure are backed by Azure Service Fabric. So the same methodology Microsoft uses, proven more than 5 years, and a lot of investment and is there around the service fabric. So thank you. That's all. Keep on liking and comment. I will dive in more into